All right, so we are here talking about 7. Which of the following photon wavelengths could possibly, typo, be in the emission spectrum of this atom when it's in the n=5 state? All right, so let's just talk about what that means. That this electron is up here, excited to the n=5 state, and there's so many different ways that it can go back down. It could go from 5 to 4 to 3 to 2 to 1. It could skip a step and go straight from 5 to 3 and then go from 3 to 1. It could just go straight from 5 to 1, but it can only be on the steps 5, 4, 3, 2, and 1. That's how this atom can emit light when it's in the n=5 state. And we're asked what wavelengths could be in this emission spectrum. Well, the graph here doesn't show me wavelengths, it shows me energies. So I need to relate them using E=hc over lambda. This one is easiest solved if we actually solve for the energies of these ahead of time. And I can do that right now. It relates, if I look at this, I say h 4.14 times 10 to the negative 15th times 3 times 10 to the 8th divided by the wavelength, 650, definitely converting to nanometers. So that's 1.91 eV, or converting from nanometers to meters, I should say. So you want to take some time to do that for each one. And I'll just do that right now. So feel free to pause the video right now. And that was 7.67 EVs. Awesome. So I just did that 4 times and got the different energy level, the energies of these 4 photons. It makes sense because I see smaller wavelengths, higher energy. That's what I'd expect from E=hc over lambda. That a small wavelength means a higher energy. And now the question is, which of these could possibly be there? So let me take A as an option. Could there be a 1.91 or 9.91 EV photon? Well, no. None of these are 1.91 apart from each other. So I'll never see a 1.91 EV photon. That will not be there. Could I see a 2.75 EV photon? Yes. That's the difference between the n=5 state and the n=4 state. They're 2.75 apart. That's why that's the answer. There's nothing that's 4.9 or 7.67 apart from each other. So they are we're never going to find those specific photons. So the only one that works is B, because 2.75 EV is the difference between the 5th state and the 4th state, because the 5th state has negative 4.9 EVs and negative 7.65 EVs, and the difference between them is 2.75 EV.